All right, we are going. Hello, everyone. My name is Mr. Barden. You probably are familiar with me from my other videos on the channel if you're watching this one. The short version of the intro here is that this is kind of a teacher's addition to the various programming digital media content that I already have up here. So if you're not a teacher teaching this or a fairly similar course, this may not be the most useful video for you to be watching. You can, if you have questions about certain things, definitely put those in the comments. But check out some of the other videos I have on this channel and just across YouTube and other websites. They may be a little bit more useful for your needs. If you are a teacher for this or a similar course, uh, again, this I'll kind of be going through the course content, but I'll be kind of jumping off and going over other relevant ideas and concepts for teaching this that I've kind of come across in my years doing so. Um, all right. The only other thing is, again, normally I kind of stream these. They aren't very scripted. It's just kind of off the cuff as we go. There's some rain coming through, and I don't often lose power when this happens. But the internet tends to be a little extra wonky. So I'm going to be recording this and uploading it, but it's still going to be the same kind of format of it's going to be very loose, open-ended, and we're going to kind of go from there. My goal, if you can't tell from the description and the title, is to get through the kind of first few lessons in the book, kind of some of the basics of coding, um, using things in P5, and then putting stuff on the screen. That's kind of where we'll end today. Um, so with that being said, if you enjoy the video, you learned something, definitely give it a like, comment, subscribe, all the boring YouTube stuff, and let's just jump right into it. So I've got pulled up here the a sketch in P5, and actually I'm going to name it because the first thing you should have your students do is name their sketches, because again, it's very hard to figure out what is what once they start getting more than about 10 or 15 sketches on their account. So this will be the intro video sketch, specifying teacher this year. Okay. So there, you can name them whatever. I usually give my students guidelines for what to name their project, at least for the big important ones. If it's something really small and simple, I don't always put that into the assignment description, but it's not a bad idea to make it part of the grade that they have to name their projects properly. It's just good to get them in that habit right from the beginning. Okay, so let's just hop right into it. We've had your students made a sketch, and if they click run, there's this gray box that appears. What is actually happening in terms of P5 is we have these two functions that start off every sketch by default. We have the setup function and the draw function. So setup is a function that is going to run at the beginning of the sketch. So whenever you press the play button, kind of the first thing that happens is setup, and it's going to happen one time. All right. And this is essentially, well, setting up everything that your sketch needs to run. So a lot of, again, setting default values, creating all the various elements we're going to be using. This kind of thing tends to happen in setup. And again, it only happens one time. So by default, we just make the canvas, and we give it a specific size right here. Again, we'll get into this with more detail as we go along, but this is very different from the draw function. The draw function loops again and again and again every frame. This is happening multiple times. I like to think of it as making a flip book. Maybe you have a bunch of post-it notes or whatever, and you can flip through it, because we're essentially making and drawing a frame. Um, in this case, we are just setting the background of the canvas to be this particular value. If I wanted to change it, I'm going to turn on auto refresh for this sketch. But if we wanted to change it, we can make it darker. We can make it lighter by going between 0 and 255. We could make it pink. And boom, it's there. One thing that's kind of popped up with a recent update is now whenever you type in a color value here, it will pop up with a little square, and you can see it, and you can actually, oh, this is really cool actually. If you click on the square, you can specify Maybe I want, oh gosh, you can specify some of that. We'll go back to here. But you can be like, I want this color, right there. We don't need this extra bit. And now we've found that particular color. Or, again, some of the basic web editors, color palettes, things like that. So if I want this color, then we'll stick it, and it'll build that color that we need. I'm gonna not go into too much detail. We're just gonna put this back at the default 220, this kind of gray color, and we're gonna move along. But that's just a new feature. I haven't explored it very much. In fact, that was me exploring it a bit for the kind of the first time just right now on camera. Um, but anyways, so we can set up all that. But whatever you put in the draw function is going to repeat over and over and over and over again. The speed at which it does can vary. I'm going to put it in a console.log command. And we'll just say, hello world, um, capital H. We can see that this is displaying, this is repeating. So far we've gone through this many frames. Maybe instead of that we could say the frame count, and now we can see how many frames we've got total. We could do frame count divided by 60. Maybe not. Oh no, that's it. That's what I want. I don't want frame count. I want frame rate. There we are. So this is a function, and you can use it to set a specific frame rate, but you can also see what your frame rate is just by calling it like so. And again, we'll go into all this in a bit more detail, but you can see that it's hovering right about 60 frames per second. That's fairly common, but the speed does vary a bit based off of your internet connection and everything that you're trying to do. So the more complicated loops and computing and everything that's taxing the resources, as well as the worse your internet connection, this may start to dip down. So you may notice that at your school it may be 15 frames a second. It may be 30. It could vary depending on your internet connection, what the code is doing, and other factors getting in the way. I have pretty fast internet normally. Again, it's been fairly consistent, but it does kind of waver a bit more, and I've got some weather coming through, which is causing that. But it's just Ethernet ported it right into my my router, so it's fairly consistent most of the time. So we've got that there. That's what I wanted to pop up, is that this is all done on the cloud through your web browser, through the internet. So again, having you know very complicated things or a bad internet connection can slow down your sketches. So that's just that. I'm just going to clear all this, lower it back down, and let's kind of get into it a bit more. So I'm going to go through these first 3 sections, I guess 4 pages right here, basically up until the variables section. So I'm going to have variables and the second half of this intro chapter done in a separate video. And then chapter 2 is going to be probably 2 or a video per thing. So conditionals, arrays, loops, that'll all be a video. And then functions, objects, and classes, those will all be separate videos, just so you have an idea of where they go. I would like to have maybe one a day as I go through all of this. We'll see. It's going to be a little up in the air. But let's just jump to it. So, elements of a web project. I've talked a bit about this already, but you can see here we're setting up all this stuff. So this particular one has the background in the setup function. So we've set the background one time, again, once at the beginning. We are not currently redrawing the background. So anything that we would put on the canvas, you would see forever. So if I just did 20 comma 20, oop, not that, 20 comma 20. I'll explain what I'm doing in a second. fill green. We are, and I rerun this. So now you can see basically, I'm just putting a circle wherever my mouse is, but because you aren't drawing a new background in your draw function that happens over and over again, you can see that all the time, every previous one. Basically, what is happening is if you were to take this sketch and rotate it kind of in a third dimension that we don't actually see, we are drawing a single frame, and then we're covering it up with the next frame the next time the draw function loops, and it's happening 60 times a second on my computer. So we are just adding the frames on top of each other. We can put the background into the draw function, and what this will do, there we are, is now the very first thing we are doing is covering up the old frame with the blank background and then drawing all the stuff on top of it. So now we don't see the old ones. That's why by default, background is in the draw function. So that's just what's going on there. All right, I talked a bit about the HTML, the CSS, the JavaScript. In my last video, one thing I like to kind of equate them to is if you've ever gone into a store, like let's say a clothing store, and you've seen a mannequin with all the clothes on it. The HTML file in relation to what we're doing here is kind of equivalent to that mannequin itself. It is the structure. It has all the parts we need, and it is holding everything together. The CSS file, which we are not going to talk about at all in this class, it just exists, and it's a thing that you do with web development and web coding. So if you go down that line, your students will learn more about it, but that's not something we cover as part of this class. But this is like the clothes that you put on the mannequin. Again, style is part of the name. And again, so you have the mannequin and that's there, but you can take off certain clothes, put other things on that essentially changes how the code in the web browser looks and behaves. So you can get really creative doing stuff with the CSS coding, but that's not what we're going to be focusing on. And the JavaScript, this is where we actually do stuff with it. So I equate it to, you had your mannequin with all the clothes, and you come in with your JavaScript magic to turn Pinocchio into a real boy. So this is where you start being able to make the buttons do things, put shapes and colors, and have them change and interact and do things like that with the JavaScript file. And this is where we will be spending the main part of our time in the class. So most of the time you won't even have to move off the default sketch.js tab. So that's pretty handy. Data types. There's a bunch of different types of data types, but the main ones we will be using are numbers. And we've already used a few right here. And I mean, it's a number. We use basically the computer on the background. Things we aren't seeing is all this code is algorithms and math and ones and zeros and equations that are running really really quickly in the computer's brain, and we're just seeing the output of that on the preview screen here. By changing the number, we can change how the computer responds to that. So maybe I want to make this 200 by 800. Now I've got a really narrow, really tall canvas. You can swap it up to be whatever you want. I generally leave it at the 400 unless I need something of specific size or that's bigger. We can change the number to change how the shading works, things like that. A string is text and characters, including spaces, and you put those in the quotation marks to indicate that they can be single or double. I tend to do the double unless there's a reason not to. So again, we can put that there. No change. So if I made this as a string, BLUE, now it's blue. If I had that as not a string, the computer would not read it as a string. It would instead be in this case now there's a function called blue apparently, or an object maybe. But you see it's changed color, so it's something different. But the computer is not reading this as blue as a unit. It's reading it as BLUE, four separate characters. So by putting it in the quotations to make it a string, the computer is now reading it as blue. And a lot of times when I specify this as a string, I'll make those air quotes to my students. So we are making the background blue around that to indicate that is a string. So the computer is reading this string and interpreting it, essentially saying that, oh, this is that color blue that's saved in the computer's, the web browser's memory. I'll go into that in a lesson on colors a bit later on, but for the beginning of the class, I tend to focus on just using these preset colors, blue, orange, um, you know, red, very basic. You can get more specific. The coral's a fun one to work with. But basically, there's a few hundred kind of preset colors to start with. So I let my students start with the names here, and then later on, we can use the numbers to directly set these specific colors. I was playing around with that a bit earlier. But for right now, this is plenty to start with for the students. But that is a string. It is, in the quotation marks. Um, and then the last one that we are at least starting with is a Boolean value. So Boolean is kind of a logical value, and it's kind of the core of a lot of what we're going to be doing. And that is just true or false, yes or no, 1 or 0, kind of the core that binary is built out of. So we'll see a lot of that come into play. I don't know if we'll get into it today, but just remember that we have three main kinds of value. We have, numbers, which are numbers. Strings are characters that we can look at as a whole with the quotation marks, and a Boolean is a true or false value. And that's that. Um, you'll have noticed on the screen that there is some code stuff going on in terms of formatting. We don't just say make the background green. Um, if you've seen the movie War Games with Matthew Broderick, that was kind of one of my pet peeves. Is that's not how computer coding really works. You don't type in, hello, how are you, and get a thoughtful response from the computer. You can, but you have to code it, and that takes a long time, and it's not gonna work that flawlessly with something that was probably coded in BASIC in the 60s. I say that. I don't know when BASIC started, but it's an old program. It's not a very powerful computer. Um, anyways, I'm going off on tangents now. What I'm getting at is that there is a very important syntax to what is going on here. This is true for all computer coding, but I'm going to be focusing again on the JavaScript kind of things and that general area. So you'll notice that we have various functions where stuff happens. Um, we have these parentheses, and these indicate that it is a function. Inside of the parentheses, we can type in arguments, and these let the function uniquely and behave. So we create the canvas, and in this particular function's case, we are making it 400 pixels wide and 400 pixels tall. So if your students' devices are a very low resolution on the screen, the 400 by 400 may be a lot bigger compared to on mine. So that could vary. If I wanted to go into the reference and pull up, you could search for whatever. So let's just do create canvas. There we are. Boom, here we are. And this will tell you all about it. Um, and, it kind of explains that we got the width and height, and I've never used this third argument. Anything on the reference page in the brackets is optional. Um, but yeah, this will kind of explain it, and you can go in and tweak whatever you need. So maybe, it could be whatever. So maybe I wanted this to be 250, and run that, and now it's a lot taller. Cool. Um, But again, what I'm getting at is all of the functions and objects and methods and stuff like that, all the stuff that you can do something, generally will have these parentheses here. And sometimes you don't need an argument. Like up here, we don't see one. But for a lot of them, to make it a unique behavior of the computer, we give it specific values that can change how it functions. So like, for example, I've got this line right here. If I copied it and pasted it, we would get two identical lines, but maybe I wanted to swap these around, so we would get width, height, Actually, that would be what am I thinking? I want um, width, comma 0, comma height, comma 0. I should have drawn a second line. Run. I don't know why we didn't see a second line there, but normally you can customize some of that. So I'll go back to coordinates on the canvas towards the end of the video. But basically, you can put whatever you want in the parentheses, and that'll change how things function and behave in that instance. So you can have multiple uh, rectangle functions, but by changing the arguments, they're called, you can change how each rectangle looks. Um, so that's there. The most important bits for doing this class in P5 are probably the brackets. These are the curly braces right here. These are used to denote what's called scope. So when I explain this to my students, I kind of make a metaphor of a house. All right, so you have your house, and that house is your sketch. Inside of the house, you have your different rooms. Okay, so you have, let's say, your kitchen, your living room, and your bathroom, maybe an office or a bedroom, however many you need. You can add on as many rooms as you need to your house. So you have infinite space and budget to do that. You can repurpose or remove rooms if needed. But that could potentially break something, so you got to be careful when you just start removing rooms. But each of these functions in your sketch, that is a different room in your house. Every time you see a yellow word here, that's kind of a different room. And you'll have this opening bracket. If you click next to it, you'll see where the paired up closing one is. But you need to put everything that belongs in that function or in that room within its confines. So the background here in P5, it is in the draw function. If I just put it here, we got a problem. You'll get some errors and background and stuff. It's just not in the right function. It's kind of equivalent to you've got your bathroom, but for some reason your sink is in the backyard, or your bathtub is clipping through the walls in a video game and it's in 3 different rooms at the same time. It becomes a problem. So I'm gonna put this back into where it should go, and everything behaves. Everything is in the right spot. So the function has a discrete beginning and end. Later on, we'll be doing things. If I don't know, I'm just throwing together something real easy. All right, so I just set up this thing right here. Um, and this is actually a test, and basically now whenever I click the mouse, it's going to put a circle in the middle of the screen. But you'll notice that, again, it's got that yellow colored character on my screen. If, so it's responding, but it's got these brackets here. So the bracket for the if that we're seeing is, it has an open and a close, but that's inside of the draw function. Again, if I was to just take that and put it here, we start getting problems because it's not inside a room in our house. It's not uh, anywhere. It can't really exist. So we got to put it in the right spot. And you have to make sure that things are in the right order. So a lot of times I have students who will have, a bunch of stuff in each other, and they've got brackets willy-nilly all over the place, and it doesn't work, but they've got all the right stuff. And it's really just because something's in the wrong spot or a bracket is in the wrong place. So you really want to tell them, okay, see where your brackets start and stop. You want to make sure that they all have a matching pair. If you are missing a bracket, it's not going to work because everything's looking for the wrong bit. So there's no paired up bracket here. This one is now paired with the next closest opening. It doesn't work. So again, every time you have an opening brace, bracket, parenthesis, quotation mark, whatever, you need to have the closing one. Now, by default, now P5 will automatically put that character right there. So if I type in a quotation mark here, you'll see my cursor is still where I'm expecting it, but P5 is automatically put in the next one, and I can just press the next one and we go there. But now I can type, and boom, that's a string. I move on to the next thing. It's already there. So that is a useful trick. When I started learning P5, that wasn't a feature, so I had to manually hit all the things. So I tend to do that as we go. Um, you know, it is what it is. But you want to have an open and a closing bracket braced all your stuff. You want to make sure that they all line up appropriately. That's where the tidy code, Command or Control Shift F, adjusts all the spacing and the lines, so you can see that okay, something starts all the way to the left and then all the way to the left. Oh, there's the closing brace, so we can see that those line up. My if starts here. We've indented a bit because we're inside of this function. It opens. The closing bracket lines up with what it should, with what it where it opens. So we can kind of see that as we move in, we are moving into little sub areas of the room. So maybe we're in the kitchen, and then we go into a cabinet or into the fridge or some little sub area. We're in the the closet of the bedroom of the second floor. We start to get more specific in where we're setting up all of our stuff. All right, so that's all right there. Again, this happens once. This checks every frame. We've got that going there. All right, working our way down. I've already talked a bit about the console. I'm not going to really go into that, but it is a useful tool, and you can send messages or or get messages from your code, send commands. It's a pretty useful tool. The other thing that is very important to mention here is comments. So I actually don't have any comments here, but if you type the slash key, the one that's also the question mark on the bottom left of a standard American keyboard, boom, right there. I guess that'd be the backslash as opposed to the front slash. But you'll notice that now everything is grayed out. And anything I type here is going to be ignored by the computer. These are comments on your code. So what they are used for, generally speaking, are leaving information. If I was to pull up, heck, I'll just pull up a sketch that I did for a video earlier today. There we are. So right here, we can see I've got everything I've typed here is more of a message for me or whoever else might be looking at this code. So a lot of times when I give my students starting codes for an assignment or a project, I'll give like the assignment instructions in the comment on the code. Or like in this case, I'm explaining, okay, here's what this bit is and what's going on. Useful information for, again, it's ignored by the computer. It is for you or whoever else is looking at the code. So again, you got the double slash, and anything after that becomes a comment. So you can put it, do I have any of that? Yeah, right here on the same line as something else, but because the computer reads the line from beginning to end, anything after that slash is a comment. So that can be useful. If you want a comment that takes multiple lines, I've got one up here. It is slash asterisk, and then everything is a comment until you get the asterisk slash to close it. So anything in between these two symbols becomes a comment and gets ignored by the computer. Okay. So that is a comment. Very useful, very helpful. You can do control or command on a Mac and that slash key to just toggle back and forth. So I can comment, uncomment. Those are helpful phrases to get familiar with. And you can use that to, maybe I don't want this here, but I don't want to delete it. I can comment it out. And it's still in the sketch, but the computer just skips through it. It ignores it. So now that circle feature, it's not there, but maybe I changed my mind and wanted it back. I can just, boom, bring it back. And now that circle feature is back in my code. So comments are a very useful tool when working on various projects. Okay, so that's this first little lesson of all the kind of basic stuff to start with. A lot of what I talked about in my last video is actually gone over in the in this lesson, this getting started lesson. So the default sketch, the files, saving sketches, stuff like that. Pretty useful to kind of go through that in a quick outline. Again, you make your sketch, give it a name, save it. When you're turning it in, I have my students duplicate it first and then turn in the new version. So now they've got two different versions. So that way they can go back and edit one, and I've still got the turned in version. Or you can make, branch it off in a different direction, see what works. It's useful to have. Maybe something gets broken and they have an older backup to go to, so they don't have to start completely over. It's good for documenting stuff and processes. It's just a overall good process to get into is duplicate and then turn in the link. But that kind of goes through that in a bit more detail. I'm not going to go through it all right now. I mentioned that again, we've got the functions here. And again, functions is where stuff happens. I kind of explained that a bit earlier today. So I'm not going to go through it in detail. If you really want to read this, I've got the link to this textbook in the video in the description down below. Um, or if you just want to pause it and look what's on the screen, you can do that too. Um, all right. Each function has an argument, like I mentioned, and these are numbers, string, values that you put in the parentheses for each function, and that changes how it behaves. It puts new things into the algorithm. That's pretty much all that's on this page. Oh, I forgot. The textbook is in the process of being updated both on the front end and the back end. So right now, navigating with these, sometimes you'll get like some PowerPoint slides, which can be useful for the teacher. I personally don't enjoy them. They were set up by someone else other than me. But I mean, if you wanted to go through everything in like a slides kind of format, they all exist here on the textbook. I don't want to get rid of them, but I do want to change how they're implemented, because if you're just scrolling through the book, it becomes problematic, and you get to the end and that's it. You can't keep going. There's no link to go to the next page. So I want to personally take all of these and put them in a separate resources tab on the textbook. Um, so that's that. So let's hit the back button a bunch of times until we get to the end. There we go. And let's jump to coordinates and the canvas. This will be the last thing I talk about today. This video actually hasn't been as long as I thought. So when we run our sketch, the very first thing by default here is the create canvas function. And this makes this box appear. Essentially, we can tell it how wide is the first argument and how tall is the second. All things in P5, but just generally coding is just kind of standardized, particularly with rectangles. You start at the top left corner and you move horizontally to the right and down. So if I made this 1 pixel by 400, it is this one, and then it goes down by 400. If I made it 400 by 1 pixel, it's 400 wide and top. So we build it. We go and build it like that from the top left to the bottom. For all of the coordinates, of 400. So for all of the coordinates, that's the same kind of orientation that we'll use. 0, 0 is this kind of top left corner. As you increase the X position, we move horizontally. As we increase the Y position, we move down. That is something that some of my students do occasionally get confused with, but they generally pick it up pretty quickly. Again, as you increase the Y value for any of this, you are moving down on the canvas. I think I've got an image here. Yeah. If any of your students take geometry and whatnot, it's basically like your computer screen is this quadrant 4 of a standard coordinate plane if they take a math case like that. So I got this line right here. I'll kind of put that into the draw function. I'll keep the conditional. So I'll go after the conditional here, but still inside of the draw function. And I'll paste that line. So now in the console, we are just displaying as an argument for this console.log the coordinate of the mouse X position and the mouse's Y position. And as I move this around, you will see that they change. So again, 0, 0 is way up here, all the way down is 400, 400, and each of these are the individual pixels of your screen. So you can get really, really specific about where you place things. You can do math to get all your stuff kind of proportionally lined up. It's pretty straightforward system. Um, but again, the canvas is this box that everything happens in. If it's not on the canvas, then you're not going to see it if you put your sketch up online anywhere. So again, you want to have it on the canvas if you want to see it. I like to think of it like, again, we're making these frames and stacking them up. So again, it would be like, your sticky note or your canvas for painting or whatever. You can paint off the side of the medium, but it's not, you've gone outside the boundaries of your painting and you're not going to see it. It's not going to be there. You have to put it on the paper to see what's happening. Okay, so this code right here, I'm not going to go through it in a ton of detail, but it's a useful way to kind of illustrate what's going on. Basically, it's just drawing a grid on the canvas. I usually give it to my students to start with, just so they can kind of get an idea. Okay, zero's up here, okay, we're about here. And they can kind of get used to placing things more by eye and more with math rather than going through and finding all of the coordinates bit by bit. So this is just kind of a useful tool, and to use this, you can just copy the code and put it in a P5 sketch. This one over here is kind of the same thing, but it's pretty a little more interactive. So we can see displayed in this box down here the current position of the mouse, and whenever you click, it will stick this little bullseye here, and it'll display the coordinates. So this is at right here in the center is 295, 267. And I mean, my mouse is one single pixel off. I'm not going to deal with lining it up, but again, this can be useful for students just getting used to uh, placing things in specific locations. Um, the next thing I talk about here is just going over um, the 4 basic shapes that we can draw here. We get into that a bit more detail later, but I kind of use the shapes as uh, a starting point for a lot of these concepts. So by the end of this intro unit, your students will more than likely be very familiar with at least these 4 shapes, that being the rectangle, the ellipse, the line, and the triangle. And actually, they have an assignment on this lesson to recreate this image pretty much exactly, if I remember right. Yeah, recreate them. So um, I guess I'll go through them right now. To make a line, you need basically for the first 4 of these, you need 4 arguments. A simple line is just the XY canvas coordinate for the one end versus the other end. So if I go in here to my draw function and we make a line, again, it's a function in P5, so it lights up blue. And we can say, let's put it at 0, 0 is the first end, and width, height. And boom, we see a line. So I'll talk more about what the width and height is, as well as mouse X, mouse Y, mouse all these pink things. The pink numbers on my screen are the data types that we mentioned. It's data, it's information, and we can store some of this, and we can refer to it with a name, and that's a little bit easier. So I don't have to remember that it's 400 by 400. I can just say, oh, the width of the canvas, the height of the canvas, and now if it changes, it'll just update automatically, which is a nice feature, but we'll get into that later. So again, there we go. So again, a line function just draws a straight line between the 2 coordinate points right here. So one thing if my students are kind of having some trouble getting it, again, these are 2 individual points, the beginning of the line and the end of the line. So I like to think of it as two-part things. You can swap the order and get the same line, so I can make it width, height, 0, 0. That didn't work, but something's behaving with 0, 0, and we get the exact same line. But if I were to swap these and make it width, height, again, we in this case we aren't having a change because the width and the height are identical. But if these were different, you would get a different option. I will almost always put width before height, unless there's a reason not to, and that's just because that is generally the standard of the horizontal aspect first and then the vertical. Um, so there's that one. The next one is rect or rectangle. And these are the X and Y coordinate of that top left corner of the square or the rectangle. So let's put it at 100, 100. The next two arguments are how wide and then tall to make the shape. So maybe I'll make it 50 wide and 20 tall. Boom, and we can set that there. I could put it, uh, if you just do three arguments, it automatically makes a square that is, in this case, 50 by 50. Maybe I wanted to make it 60 by 60. Whatever, you can set it to be whatever you want. So that's what that's happening right there. And so again, you can move these around and place them wherever you want. Maybe I want this a little bit lower, so instead we'll put it at 110. Or sorry, a little to the left, but you can, and maybe we'll make this 200. And you can place it wherever you want. But once you know that it's pretty much X, Y, with height, that's a very common arrangement. You can put things wherever you want, and that's pretty useful. The other one here, ellipse, makes circles and round things. It's very similar to the rectangle function. And that didn't go in the right spot. There we are. But, and I did this on purpose, I copy and pasted this. The rectangle, by virtue of the math needed for the computer to draw it, that XY spot here, for the first two arguments, that is that top left corner. By the same virtue of the math needed for the computer to render a circle, or an oval, whatever, that coordinate is the center of the circle. So I make a point to show my students this exact graphic with the rectangle and the circle to show that you can't just copy and paste between a rectangle and ellipse and expect it to line up. You will have to do a bit of math and nudging back and forth to get things if you really want it to line up. Doing some variables could be useful. Let's see, if I was to go about this, let's see, half of 60 is 30, 110 plus 30 is 140, and then half of 60 is 30, so 230. Boom, and now we can get it to line up, but you're gonna have to do some tweaking and some math, so to get that to happen. The last shape is the triangle, and my students tend to hate this one the most. They just don't like it. I think part of the reason is it can be a complicated function to work with until you get used to it, but once you do, it is very powerful, very handy to have, very customizable. And so, like the line where we had just two coordinate points, we'll be building our triangle the same way, but it's a triangle, so we have three coordinates. So we need 6 total arguments here. And so it's xy for 1 point, xy for the second, xy for the third. So I'm just going to arbitrarily... Why not? But when you notice the shape was getting built around here. So this can become problematic because each of these 6 points are now individually customizable, and they don't talk to each other. So if you wanted to translate this entire shape as a whole and keep the same angles and lengths and proportions, let's say you wanted to move it to the left, you would then have to increase all of the x values by the same amount. So maybe I wanted to move it 100 pixels to the left. I got to increase all of the x values by 100 to get that same shape over there. So it can be a little problematic, but they get used to it, or they just avoid triangles. But I usually make them use it a bunch of times just to get them handy. So to kind of bring this generally to an end, let's kind of pull up some comments. So with a line, you have the x1, y1, x2, y2. That's there. We have x, y, width, height. That's specifically for the top left corner, so I'll make this 60. Um, three, three arguments makes a square. 60. Again, you can add that in and now I've got an oval. This is the same for an ellipse, only instead it's not the top left corner because there's no corners on an ellipse. It is the center. And then 3 arguments makes a circle. There is a function that only draws squares and circles, and they're called square and circle. But I never teach my students this. I just give them this one to focus on, and if they want to make a circle, they know how to do it here, and it becomes one thing that they have to remember, and it's just a more powerful tool. It's basically the same function, except you can't adjust one thing. So I usually just give them these 4, and if they want to use other stuff, they can. You can explore the reference here, and if we scroll down, actually we can just find this category, shape. Here we are, 2D primitive simple shapes. So arcs we'll talk about later. Ellipse and circle we'll get to. A line, when we did a line, a point is a single pixel on the screen. Quad is any 4-side shape. Rectangle we've gone over. Or quadrilateral. Yeah, quadrilateral. A square does a square. Triangle does a triangle. And we can set different parameters about it, or we can set curves and custom shapes and begin doing 3D stuff if you want. So again, there's more stuff that you can do, but I've shown you the most commonly used and more powerful ones. All right, last one here. We get x1, y1, x2, y2, x3, y3. There we go. So again, just like the line, each of these 6 numbers are paired up. So you get, 1, 2, 3, and 4, 5, and 6, and you can technically swap them in any order and get the same shape, but you got to make sure that that you swap the pairs. So that again can be problematic. I like triangle for how versatile it is. I don't like it for how much of a pain it can be to get used to working with it. Um, all right, so again, that's that. The canvas, again, we can set these numbers, and all of these numbers, all of these arguments is a specific pixel on your canvas. With 0, 0 being that top left corner. So again, just to illustrate this, looking at the rectangle here, the top left corner of the rectangle is, if you were to zoom in as far as you could on your screen, it would be 110 pixels over from that top left corner, and then 200 pixels down. Boom, there's the shape. And then the computer fills in a rectangle that is, in this case, 60 wide and 60 tall. And you can customize that however you want. Um, that's pretty much it. I went through the basics of some of the formatting. You've got, the parentheses, the brackets. You should have a semicolon at the end of each command that you give, but P5 is very user friendly and it'll work without the semicolons. But if you tidy your code, tidy code, it will automatically add any missing semicolons. So that's another reason I have my students tidy their code frequently, and it'll just add that in. They'll get used to seeing it. And that's, again, everything in these first few lessons. Generally, I have my students from here, again, get practice building multiple shapes and things like that before we move on to variables, which is what we'll use to make the shapes change and adapt and begin to do stuff. Because right now we can do everything, but this is what's called hard-coded, meaning that this code doesn't have anything to make it adapt and change to anything. It's always going to be, with the exception of this line, it's always going to be the same thing every time I press that button. There's nothing to make it change. And that's what we'll be focusing on next time. To kind of wrap it out, you'll probably notice as you're starting out your students, the bracket thing is that's for me consistently an issue throughout the whole year. I don't know how to explain it any more clearly at the moment than whenever you open one, you have to put the closing one, and anything in between it is part of that thing. It is that, the refrigerator is the command, it is in the kitchen, which is the function. I can't make it any more simple than that at the moment. If you can think of a better analogy that works better with your students, I would love to hear it. Put that in the comments below. Um, did I miss it? I feel like I might have missed one or two things. Oh, I didn't mention this. So, um, the one thing to note is that within a function, the computer will read, left to right, top to bottom, in that, and do everything in that order. That's why we draw the rectangle, and then the next thing is draw the ellipse. So that's why the ellipse is on top of the rectangle here. If we were to swap it, we would see the rectangle on top. Um, so that's the thing inside of the functions. The functions themselves can be in whatever order you want. So I move this down here. Same thing. It doesn't matter what order the functions themselves are in, as long as all the brackets line up. But it's what's inside the function is where order begins to matter. So there's that. And just another thing I like to stress to my students at the very beginning while they're learning this, getting it worked out, is that computers are very powerful, but they're also very stupid. That being, they take things extremely literally. Like, you typed in 140 for this argument, you are going to get this ellipse is going to be right at 140, and that's it. So it's going to be very, very literal interpretations of everything you are typing. And that's going to, for a lot of students who, especially ones who have never done this before, take some getting used to. And going back and forth of, okay, well, this looks weird, there has to be a reason in the code why. And trying to find, okay, so maybe this end of this point of the triangle isn't where I want it to be. Let's find where I make the triangle and find the point that's different, and boom, you change it. It's not going to be random just errors because something felt like it most of the time. Okay, so that's that. I think that's just about it. Final tip, because I didn't write a script for this. I'm just kind of going. Is that I like to also add comments to my triangle function, and just labeling, okay, the order I type it in. So let's see, 215. That would be the top. 400, 250. That would be the right, and then left. Okay, so now I've labeled these so I know that 215, that's this point. So if I need to make any changes to this point of the triangle, I know that, okay, that's the first one right here, and I can change these numbers and leave these the same or bring it back as needed. It's just a useful tool, and it also brings back comments for the students. Okay, that was a lot of information all at once. I'm going to save this so you'll be able to find it in the description below. And I'm going to end it here because, again, I'm going to end up rambling and find something else to bring up and so on. This will be a 6-hour long video that I don't have the patience or mental capacity to do right now. So hopefully this was helpful for you all as you're kind of learning the concepts, getting tips for teaching to your students. The biggest thing you can do if you're not sure about stuff is get in there and explore it, practice it, and just do it over and over again, even if it's something really simple. And just the more times you get used to typing and coding it, the more ingrained the process and the computer logic will become in yours and your students' memories. All right, so that's going to be all for me. I will see you all in the next video where we'll start talking about variables. Have a nice day, and I'll see you the next time I see you. Bye.